Hello, in this video we're going to talk about data and visualization. So, what is in a dataset? There are two pieces of terminology that are important about datasets. Each row is an observation and each column is a variable. Here we're looking at a dataset called Star Wars that basically contains information on the characters from the Star Wars enterprise, where each row is a character and each column is an attribute of that character. The first row is Luke Skywalker, so let's take a quick closer look at him. Here's Luke. This is not the most flattering picture of him, but I thought it was the funniest, so that's why I chose it. And we know some things about Luke. We know his name. We know his height is 172 centimeters. Weight is 77 kilograms. We know his hair color is blonde. We know his birth year, so on and so forth. And we can see that some of the things we know about him are a single entry. So eye color blue, skin color fair, species human. But some of the other things are actually lists because there are multiple entries for that particular variable for him, like the films he's been in, the vehicles he's been in, and the starships he's been in. For the purposes of the earlier part of this course, we're going to focus on variables where we only have a single entry per observation, like height, weight, eye color, skin color, species, stuff like that. Later on in the course, we are going to say a bit more about list columns where we have multiple entries per observation in a column, but for now let's set those aside since those are going to require that we know a little bit more programming before we can actually wrangle and visualize those data. A useful function when you're getting started with a data set is the glimpse function, which will not only report to you the number of rows and the number of columns in the data set, but will also give us a list of the columns. So usually if you have a wide data set with lots of columns, in the earlier representation we couldn't see all of their names when we were looking at it as a data frame. So this is a nice way of getting a list of all of those columns down, just down a single column. Next, we know something about the types of those columns, like I'm seeing some letters here, CHR, that stands for character, int for integer, DBL for double, and I'm also seeing that name list that we've seen talked about a little bit earlier, where we were saying that things like films, vehicles, and starships are list columns. For the time being, I'm going to omit this column. I'm going to omit talking about this column from the glimpse output, because a little bit later in the course we are going to say more about formal data classes and data types in R. Next, we can see a few of the observations from each of the columns. The first observation for the name is Luke Skywalker. The next one is C3PO, the next one is R2D2, so on and so forth. So under this glimpse representation, we can not only see the columns, the names of the variables, but we can also see a few observations from each of them to start getting a feel for the data. This particular data set is distributed with one of the packages that we are going to be working with. The name of that package is dplyr, and it is the data wrangling package in the tidyverse. And since it comes with a package, it comes with documentation as well. So I can, just like any other function that is distributed with a package in R, for any data sets that are distributed with a package as well, I can use question mark and then the name of that object, so the name of the data frame, to bring up its documentation. And in the documentation, I can see the names of the variables and then their descriptions. This is what we usually refer to as a code book. And when the data set is distributed with a package, we have it readily available for us. A little bit later on in the course, we're going to be bringing in our own data sets that don't necessarily come with documentation with a package, which means that we're going to have to I will either have to provide you code books, or in the case where you're finding your own data set, like for your project, you're going to be writing one up. So the number of columns and the number of rows in this data set are also given to us in the documentation. We have 87 rows and 14 variables, so 14 columns. And we know that each row represents a character from the Star Wars enterprise. And we also have gone through what each of the columns mean roughly as well. Other ways of accessing this information is more programmatically. We've seen the nrow function before for getting the number of rows in a data frame. So it's the name of the function and then in parentheses what we want to apply that function to. So that's nrow Star Wars is 87 is the number of rows. Another similar function is ncol, which will report to us the number of columns, which is 14. Or I can get both at the same time with the dim function, which gives me the dimensions of the data frame. And they're always in the order row and then column, generally the same way that you would refer to matrices. Now that we know a little bit about how data frames are represented in R, let's start talking about exploring them. So exploratory data analysis, or EDA for short, is an approach for analyzing data sets to summarize its main characteristics. Often, this is visual, and this is what we're going to focus on first, but we might also calculate summary statistics, perform data wrangling, manipulation, transformation at or before this stage of the analysis, and that's what we're going to focus on next. Here's a data visualization from the Star Wars dataset. On the x-axis, I have the heights of the characters, which is reported in centimeters, and on the y-axis, I have the weights of the characters, which is reported in kilograms. In general, how would we describe the relationship between mass and height of Star Wars characters? Well, if we're looking at humans or mammals or animals that you can think of, usually height and weight tend to be positively associated. The taller somebody is, the more they might weigh on average. And we are perhaps seeing slightly increasing trend here in the points at the bottom, but it's actually really difficult to get a sense of what's happening for the majority of the characters in this data set, because all of the data are squished to the bottom of this plot, and we have this one character that's not so tall, but really chubby, that's sticking out like a sore thumb in the middle that I've circled in pink in the visualization. So let's think about why might this be happening in this particular data set. Well, in this data set, we don't just have humans, we also have droids, for example, and who knows what the relationship between their heights and weights are. So when we think about what other variables would help us understand data points that don't follow an overall trend, one thing that we might think of is the species, because depending on the species, we might actually observe different relationships between height and weight. So let's think for a second, who is this not so tall but really chubby character? If you are a Star Wars fan, you probably got this already. But even if you know very little about Star Wars, you're probably going to recognize this little character, Jabba, who is, turns out, not so tall, but really, really chubby. All right, so let's talk in general about data visualization a little bit. I have here a quote from John Tukey, who is a statistician, and the quote says, "The simple graph has brought more information to the data analyst's mind than any other device." Said simply, a picture is worth 1,000 words. So data visualization is the creation and study of the visual representation of data. There are many, many tools for visualizing data, and R is only one of them. And within R, there are many, many approaches and systems for making data visualizations. ggplot2 and R package is one of them, and that's what we're going to use in this course. ggplot2 is the data visualization package in the tidyverse. The GG in ggplot2 stands for Grammar of Graphics because the package itself is inspired by the book Grammar of Graphics by Leland Wilkinson. So here's a picture of that book. It's not one of the required readings here, but if you are interested in getting into the theory behind how we construct visualizations with ggplot2, it's a really, really good read. A Grammar of Graphics is a tool that enables us to concisely describe the components of a graphic. And here are the components that are described in the Grammar of Graphics. We start with the data, then we add aesthetics, then geometries. We might facet our visualization. We might calculate statistics and represent them on our visualization. We might change the coordinate scale or customize it. And then finally, we might apply a theme. We're going to go through and talk about each one of these layers. And something to keep in mind is indeed the word layer, because we're going to be building our visualizations in layers like this, just like it's represented in this illustration here. So here is the code that produced that visualization we saw earlier. And we're going to go through and dissect this code one by one. But I also want to take I want you to take a look at the code for a second and try to think about what are the bits and pieces in that code that actually are things that I can see in my visualization. I think things that are easiest to identify actually are any of the character strings. For example, the title of the plot is mass versus height of Star Wars characters, and that's what I can see represented on the title of my plot as well. On the x-axis, I have the character string height, and then in parentheses, centimeters to indicate the unit of measurement. And on the y-axis, I have weight, and then in parentheses, kilograms, again for the unit of measurement. But let's take a look at the rest of the code that's actually doing the plotting a little bit more closely. So what are the functions doing the plotting? The main function in the ggplot2 package is the ggplot function. Each one of your visualizations is going to start with this function. And the first argument that we feed to this function is the data. Just like any other tidyverse package that we're going to be learning about, the first argument is always going to be the data frame that we're working with. So in this case, data is the name of the argument, and Star Wars is the data frame that I actually want to plot. Then what I want to do is I want to do some aesthetic mapping. So if we actually think about the illustration we saw earlier in terms of the layers, we started with the data and then we added aesthetics. So in our aesthetic mappings, we are saying that the height variable should be mapped to the x-axis and the mass variable from the data set should be mapped to the y-axis. Another function here is the AES function then, since it's being followed with parentheses, we know that that's a function. So that is the function that actually takes the variables from your data frame and maps them to aesthetic elements of your plot. And then another function we have is geom_point. So once we have our data and our aesthetic mappings, then we add our geometries. And here what we mean by geometries is what sort of a geometric object should each data point be represented with on my visualization. I want each data point to be represented as a point. So the function that I use is geom_point. Throughout the course, we're going to teach you a variety of geoms, and also for some of your assignments, we're going to expect you to read through the package documentation to find about geoms that we may not have explicitly touched on in the course videos, but that you can discover yourself and start using. And finally, the last function we're using is the labs function, which takes the character strings that are fed to it, like for title, X and Y type aesthetics, and then places them onto your graph. So one other thing that we're seeing here is a warning. The warning says that remove 28 rows containing missing values. And then in parentheses, it gives us the geom for which these rows were removed. So what this is telling me is that 28 of the rows are not being represented in that visualization that we saw earlier. And the reason for that is that for 28 of these rows, we are probably missing height or weight or both. So if there's no height or weight or both recorded for the character, there is no way to represent that character on our visualization. So ggplot2 is actually being very explicit and telling us this. For the remainder of the videos, I'm going to suppress this warning just to save space on my slides. And you might do similar things when you're doing any sort of reporting, but it is important to take note of it. And it's important to acknowledge that this is happening and explicitly decide, I'm okay with it. And I'll consider that. I'll make sure that I keep that in mind when I'm doing my interpretations later on, or I'm not okay with it and I need to go back and fix my data set. So, hello ggplot2. As we said, ggplot is the main function in the ggplot2 package, and we construct our plots in layers, and the structure of the code for plots is very similar to what we just saw. We always start with the function ggplot. The first argument is data, and we feed it the name of the data set that we want to plot. The second argument is the mapping argument, and here we do our aesthetic mappings. For now, I've only given you X and Y, but we're going to talk about other aesthetic mappings as well. And then we tell ggplot2 what sort of a geometric object do we want each of our data points to be represented with. So that's some geom layer that we add to it, and then other options. all of which are optional in the sense that your plot will be something recognizable as a plot with just these two layers, but chances are you want to touch those other options so that your plot is actually looks good and easy to interpret as well. The ggplot2 package comes with the tidyverse, so instead of loading it explicitly, we're always going to just load the tidyverse package, and it's one of the 8 packages that comes along with it. If you're interested in help with ggplot2, the ggplot2 website is incredibly useful. And here you can see a bunch of useful things. You can see a link to the cheat sheet, which is handy to have available to you whenever you're, especially when you're first learning, but even when you're kind of improving upon your plots after you get the basics, you'll see kind of all of the useful options the ggplot2 package offers here. Similarly, under the reference tab, you can see a list of all of the functions that are available with the ggplot2 package. So here, for example, the various geoms, we talked about geom point, but you can see there are a variety of different geoms that we can use for constructing our visualizations. And I'm going to just open up one of them. So how about we open up, for example, geom hex, where we do hexagonal binning of the data that's useful for large data sets. And one thing I want to show you here is that even though this information is the exact same information as you would get if you were to call the help file for geom hex in RStudio and have it open up in the little help pane. Here, not only do you see the examples with the code for the examples, but also the output. And this sort of output is not going to be available to you in the help documentation within R. You would have to run the code to see that. But I find it incredibly useful that I don't have to run any code. I can just take a look to see, is this the sort of thing I want to make? And if so, I know this is the geom I need. And if not, maybe I go back and say, maybe that's not what I'm really looking for. I'm going to go ahead and take a look to see if this is the sort of thing I need. And again, I can actually see the resulting plots from the examples here as well. Let's wrap up this video with a discussion of why we might want to visualize. So here's a data set. It's called the Anscombe's Quartet. And what is special about this data set is that you can see there are 44 observations in the data set, and there are 4 groups of data that's being represented. 11 observations for set 1, 11 observations for set 2, 11 observations for set 3, and 11 observations for set 4, each designated by this Roman numerals in the set column. And for each of these observations, I have an X and a Y coordinate. So the first thing I'm going to show you is summary statistics about this data. And I'm going to ignore the code for a second and take a look at the output. We can see that for each one of the sets, 1, 2, 3, and 4, the mean of the X coordinate, so the mean value of the X coordinates given for these data is 9. The mean for the Y is 7.5. The standard deviation for the X is 3.32. The standard deviation for the Y is 2.03. And the correlation, which measures the strength of the linear association between X and Y, is 0.816, and only for one of the sets, it's 0.817. But the important thing is that these summary statistics are either exactly the same for each one of the sets or very close to each other. And in terms of the code, how we got these summary statistics is that we started with the data set that we were looking at, the quartet data set, and then we piped it into the group by function, which is going to organize our data based on the groups indicated by the set variable, which had the Roman numerals 1, 2, 3, and 4, and do all the subsequent calculations for each one of these groups. And those calculations are things like, give me the mean of the X's, give me the mean of the Y's, give me the standard deviation of the X's and the standard deviation of the Y's, and then give me the correlations as well. And on the other side of these equal signs, it's basically just the custom name that I'm giving these statistics. We're going to talk a lot more about data summarization using data pipelines like this a little bit later in the course. And you've already seen a little bit of this in the introductory material as well. So for now, instead of focusing on that particular code, I want you to take a look at the output and take note of the fact that all these numbers are the same down each of the columns. But if we were to visualize the data, so here is a scatter plot of X versus Y for each one of the groups. So for group 1, 2, 3, and 4, and we can see that no way are these sets equal to each other. So the summary statistics tell one story. They make it seem like each one of these sets are exactly the same, but the visualization tells another story. So this is a motivation for making data visualizations as opposed to just using summary statistics to learn about our data. Now you might be thinking, well, obviously these data are made up. In fact, they're true. This particular data set was put together to show that for certain data sets, you might have characteristics like this, and the only way to uncover that they are different, that the relationship between X and Y are different for these sets, is to actually take a look at a visualization. But let's look at some real data too. A few years ago, I did a survey in one of my classes, and the students actually came up with the survey questions, and I'm going to give you visualizations based on 2 of those. One of the questions that the students wrote was, how old were you when you had your first kiss? And here we have a histogram of the responses. Do you see anything out of the ordinary here? We have some people who are saying that, or many people who are saying that their first kiss was around age 15. But then we also have some people at the very bottom of the curve where we're seeing that they're saying their first kiss was around age 1, 2, 3, or 4. So what is happening here? I think the survey question was asking about a romantic kiss. And that's how majority of the students interpreted this. And so they gave some answer, that centers around age 15, which sounds reasonable. But perhaps some people who responded to the survey were thinking, well, I'm sure my mommy kissed me when I was first born, so I'm going to put a really, really early age, or the first age that I can remember anybody kissed me. So this is a situation where the survey question wasn't precise enough, and hence the responses from the students are actually to 2 separate survey questions. Some really thought about the first kiss ever, and some thought about the first romantic kiss. If we had just looked at summary statistics from this data, we would probably find that the mean is somewhere around age 15 or so, and we would have moved on thinking that sounds reasonable, and we would not be able to necessarily figure out this other trend going on. Here's another question from the same survey. How many times do you go on Facebook per day? So the question I want to pose is, how are people reporting lower versus higher values of Facebook visits? It looks like at the lower end, people are being more precise. So for example, if you have told yourself, I'm only going to check Facebook morning, afternoon, and evening, I'm not going to spend a whole lot of time there, then you probably know exactly how many times you're checking it, and you might precisely give that answer. If you're a person who is on Facebook all the time, like the person who responded 200, chances are you don't actually know that number by heart. You're kind of guessing a really, really large number. So as the frequency of Facebook usage seems to increase, it looks like there's a lot more rounding going on than at the lower end of these observations. And this again is a characteristic about the data that would be impossible or very difficult to glean from summary statistics, but is very visible to us from a visualization.